מפתח בטמבלר. אני גר עכשיו בניו יורק, לפני זה אני נולדתי בירושלים, עברתי לארצות הברית בגיל 12, הייתי כמה שנים בקנדה, עכשיו אני בניו יורק, אני מפתח אנדרואיד בטמבלר. דרך אגב, טמבלר אמנם חלק מיהו, בקרוב חלק מוורייזון. אוקיי, אז אנחנו פה בשביל לדבר על מה שנקרא Dependency Injection, ואני תכף אעבור פשוט לאנגלית כי זה פשוט יותר נוח לי, אבל אנחנו נדבר על מה זה בעצם Dependency, מה זה Dependency Injection, מה זה Dependency Inversion Principle, שהוא בעצם משהו נורא דומה אבל שונה וההבדל הוא די חשוב, ואז נדבר קצת על frameworks. אז I'll switch to English now. So what is a dependency? Dependency, simply speaking, is the relationship between two classes, two objects, basically two things. And then usually it's one item that depends on the other. Class A depends on class B. And you see this in our code basically everywhere. If you have an app that uses contacts or basically reaches out to an API, you have a dependency on HTTP. If you have some sort of image library that downloads images and displays them, you have a dependency again on HTTP. If you have a REST client, you depend on that REST client, and that could depend on some sort of a deserialization library, such as JSON. So this happens everywhere, and it helps kind of separate the way you write code, separate your modules into different kind of concerns. So someone can write the database layer, and someone else can write your network layer, someone else can write your front end. And usually, or a lot of times, it'd be somebody you don't even know. It'd be a third-party library that you use that you're dependent on. So if we just look at a simple example of what a dependency is, you have this class called example, and it depends on a class called database helper. And you can't use example without actually having an instance of database helper. And we can say that the example class is tightly coupled to database helper, which means it won't be able to run, won't be able to compile without it. So when we write our code, we want to kind of decouple those two. We want to make sure that example can exist without database helper. And the way we do it is we use something called dependency injection. And that's a software pattern that helps us separate these two objects so they can live independently of each other. Just the dry definition is dependency injection is a software design pattern that implements inversion of control by resolving dependencies, and an injection is the process of a dependency to a dependent object to use. So while I was doing kind of research for this presentation, I came across this really great quote that sums up the concept. And it says that dependency injection means giving an object its instance variables. And that's it. It really is that simple. It's just a fancy way of creating an object that isn't tightly coupled to its dependencies. So if we go back to our previous example, the one that doesn't use dependency injection, as we saw before, in the constructor of example, we had to create our own instance of database helper. And if we look at an example that does use dependency helper, we actually pass an instance of database helper through the constructor. So it has a reference to it, but it doesn't actually have to construct it. It doesn't need to know how it gets constructed. And it's important to note that the only difference here is this creation of the database helper class. So this type of dependency injection is called constructor injection because it is passed through the constructor. And then there's another type which is called setter injection or instance injection, which is just you create a setter and you pass to it. Sometimes that's your only option. We're Android developers. We never create our own activities. This is your only option. And this is dependency injection in its purest Java form. And you might be asking yourself why we want to do this. So the first really big benefit is that you can share dependencies. You can create one HTTP layer that you share in different parts of your app. It also allows you to configure your dependencies externally. Sometimes it's just you have objects, you have dependencies that are really complex and really heavy to kind of configure, and they take time. The classic example is HTTP with its abundance of options that you can give it. And by kind of setting that, giving HTTP to whatever thing that needs it, that thing doesn't need to know how to create HTTP, it just needs to know how to use it. The other thing that it gives you is, it's kind of a side effect that by doing things this way, you separate what each class in your application does. So one class that deals with, let's say, loading your user profile from the API doesn't need to know how to create a connection pool. It just gets the connection pool, the HTTP client, it says, give me the users, I'll deal with that. And you deal with connection pools, you deal with whatever happens. If the server throws an error, you deal with that. All I care about is the users. And then the last benefit, and in my opinion, the most important benefit, is it creates an inherent testability in your code. Because you no longer depend on a specific implementation, you can actually mock out that dependency, replace it with something else, and then you can test based on that. So in the previous example, we had a dependency on the database helper. Now we can pass a mock database helper, and just after cloning do stuff, we can assert that it was actually cloned and it did something. All right, so now that we kind of understand what dependency injection is in theory, I just want to quickly talk about the dependency inversion principle, which is also called sometimes the inversion of control principle. Just because they're very similar, but they're different, and people tend to mix them up. So the dependency inversion principle was defined a long time ago by Uncle Bob and a bunch of other smart people as part of the solid software design principles. So the definition is high-level modules should not depend on low-level modules. Both should depend on abstractions, and abstractions should not depend on details. Details should depend on abstractions. Now that's a very dry and kind of hard to understand definition, and it doesn't really help understand what it is. So let's just go through an example, and it should become very clear. So back to our definition of dependency. We have class A depends on class B, which is another way to say that class A is coupled to class B. There's a certain relationship between A and B, and how tightly they are coupled kind of has a direct effect on how hard it is to modify the way they interact. So let's say we're writing some sort of an ebook reader application, and we want to have very basic features. We want to be able to read or support only PDF books, and we want to be able to basically flip through the pages one page at a time. So a really simple kind of naive implementation would be to create one kind of controller object, and then a PDF reader helper object, and a display printer. And then the reader kind of takes the book, you tell it which page to load, it gives you a string with all the content in that page, and a printer, which you give it the string, and it just prints it to the screen. Very simple stuff. So if you go and you code that up, it's a two-line kind of code snippet. You take the book URI, you pass it to this helper object to read, you take the result, you pass it to your display helper, and you print it out. So you code this up real quick, you go to your manager, you tell them, hey, I built this great app, it meets all the requirements we had, let's go ahead and watch it, and launch it. And as soon as you do, your manager kind of goes and tells you, hey, so we did some market research and it turns out that users kind of want more than one type of books. They don't all use PDFs, they use EPUBs, they use iBooks, they use a bunch of other formats. So let's go ahead and build support for that. So you go, you look at your code, and you're thinking, well, this only supports PDFs. How do I add support for other book types? So you think about it, and you decide, I'm going to predefine all the book types that I know of, and I'm going to pass the book type, and I'm going to have an if-else statement, and I'm going to read, and based on the book type, I'm going to read the file, and pass that to the display, and I'm done. Very simple. And you go back to your manager, you say, great, I did it, it wasn't too hard, and the manager said that turns out that ebooks now come as a standard feature. You can actually read aloud the books. So you have a new requirement. So you think about the new problem and you realize this is a very similar problem that you just had with the book types. You actually want to predefine the output types, your printer types, and you have the same solution. Then you have an if-else statement with all the existing output types, and you think, great, new types. Every time I need to add a new type, just add another line, and it's real easy. But it becomes real clear that there is a problem here. Two problems, actually. First, every time we want to add a new book type or a new output type, we have to go and modify the load page method. And the second is, how do you actually test this? Do you have someone load a PDF book and flip through every page and make sure that everything is displayed correctly? So as this implementation is right now, load page depends on your PDF reader, the EPUB reader, the screen printer, and the voice printer. And there is no way to actually call load page without calling methods on these dependencies. So this really doesn't scale. And this is where dependency inversion comes into play. So if we remember, our definition is your high-level module should not depend on low-level module. It should depend on abstractions. And your abstractions should not depend on the details. Your details should depend on abstractions. So let's kind of apply this principle to our app. So we start again with our high-level cool ebook reader. Since it kind of performs the logic of kind of wiring and connecting all the parts together. And then the dependency inversion principle says our high level should depend on abstractions rather than implementations. So let's have it depend on interfaces for the reader and printer operations. All right, so we have our interfaces, and the readers would be responsible for reading ebooks, and the printers should be responsible for taking strings and printing them to something. So the next part of the definition is that abstractions should not depend on details, rather details should depend on abstractions. So our PDF reader has to implement the interface of reader. Whether it needs to do other work, we don't care. As long as it implements the methods that reader tells it to, and it returns the correct information, we don't care if it needs any other, basically, information. Same with the display printer. As long as we can give it a string and it will know what to do with it, that's all we care about. So we go and we code this up, and now instead of depending on the PDF reader and the display printer directly, our cool ebook reader depends on the reader and writer interfaces rather than it depends on the interfaces, and it delegates to their predefined methods. And if we compare this implementation to our very first implementation, the original code, you'll notice that it's basically the same thing. The only difference is you pass the dependencies now, and you call methods on those dependencies rather than having them basically predefined and being coupled to those implementations. And in the future, if we want to support other book types like iBooks, all we have to do is implement the reader interface, pass it into this function, and it just works. You don't have to actually go and modify ebook reader. And of course, I said the biggest advantage of doing things this way is that it's testable. So let's just write a quick test for it. Now we can just pass a mock reader and a mock printer, pass those two mocks into the load page method, and make assertions to make sure they were called correctly and in the right order. And that's basically it. So we talked a little bit about kind of the raw Java dependency injection, dependency inversion. But what's next? We haven't talked about how you actually create dependencies. We talked about passing them, but not about where we actually create them. And all of us work for actual companies. We write actual apps, and we have thousands and thousands of objects. And you can't just create everything at the beginning and pass it around. So this is where kind of dependency frameworks come into play. So why use a framework? Like I said, it handles the object creation for you. It kind of centralizes where you create objects. It lets you organize based on your concerns, based on what the objects do. If they're related, you can put them in one place. If they're completely different, put them somewhere else. It reduces a lot of the boilerplate code. Central location. And the better frameworks kind of help you implement common engineering patterns, kind of like singletons, lazy loading, multiple injections, stuff like that. And just before we go into the specific framework I want to talk about, just a quick warning, adding a framework, adding libraries to your project is not something you should just do all the time. It increases the size of your APK. It's a new skill that your engineers, your developers have to have, and the library can just go, the project could be abandoned, and then you're left kind of either having to abandon it yourself or start supporting and maintaining that library yourself, or the library may change in a way that you don't really agree in the future. So choose wisely. Basically choose the library you use wisely based on your best judgment. Okay, so common frameworks, and I'll focus mostly on Android stuff. At least in the Java world, most frameworks can be divided into two camps. The first one is frameworks that use reflection to create objects. The other ones use compile-time code generation. Reflection-based frameworks tend to be a lot simpler, a lot easier to learn and use, but they're slow, and that's a big problem on mobile devices. Reflection ones are usually kind of server, where you don't care if it takes 5 seconds or 20 seconds to start up a server, because it's going to run for months at a time. In your Android apps, that's a huge problem. Compile-time frameworks typically use a mix of annotations and configuration files to generate all the code you need to inject dependencies. And the way you actually configure it kind of is dependent on the framework you choose. I don't know if you guys saw Jason's kind of presentation earlier today, but he kind of showed how you actually take an annotation, turn that into actual code that you can use in the app. So there's a bunch of frameworks out there for you to use. Some, like Spring and Pico container, are server and backend oriented, and some are were server backend oriented and then got ported to mobile. Juice is a good example of that. And others were written specifically for Android. So the first one that was made specifically for Android was RoboJuice. And anyone used that before? You like it? Yeah. RoboJuice is a port of the full Juice library, and it never really caught on with anyone. And the reason is it was super slow, super heavy, and had more problems than it helped. And then the same goes with Spring's attempt at DI frameworks for Android. And then in 2013, the first version of Dagger was released by Square, of course. And its biggest goal was to fix the obvious things that were wrong with Juice and RoboJuice. In fact, the project webpage still has a guide how to port over your app from Juice to Dagger. And it proved to be so well done, so well executed, and so popular that in 2015, Google actually forked the project, brought it in-house, fixed the last few reflection-based code in Dagger 1, released it as Dagger 2, and it's now officially supported by Google, and it's 100% reflection-free. So it's all generated code. One thing I'd say is if you are already using Dagger 1, there is very little reason to switch to Dagger 2. The improvements are not that much. The syntax is very similar, and the performance improvement is very, very negligible. And then literally about a month ago, a new framework came out called Tiger, and the author of this library claims that it's around 100 times faster than Dagger 2, but I haven't had a chance to use it yet, so I can't tell you if that's true or not. But for the time being, let's talk about Dagger 2, and kind of what it can do for your apps. So like I said, Dagger is an annotation-based tool, meaning that Dagger uses very concise code. You describe what you want it to do, and it does it. It's very, very simple once you get it set up. It's very simple to add more injection points, to add more objects that you want to inject. Yeah. So Dagger uses 4 basic annotation types. The inject annotation, the module, component, and provides. And you'll notice that inject, I wrote the full package name, and that is because that's part of the Java standard 330, which describes 3 or 4 annotations that should be used by all dependency injection frameworks. And Dagger provides a ton of other annotations that you can use, and some that you can actually extend for custom behavior. But for now, let's focus on these 4, and then I'll go and show you kind of what you can do with the other ones. So the best way, of course, to understand this sort of stuff is to see an example. So let's write a very simple app that can tell you whether you're connected to the network or not. So here's the connection helper class, our dependency, basically. It takes in a context. It gets the connectivity manager from the system. It checks whether you're connected, and it just returns that. And you just notice that we used, we pass it a context that it can generate everything it needs from. And now whenever we actually want to use it, we grab a reference or we create this connection helper, and we ask, are we connected or are we not? So here's inject. This is how we tell Dagger how to construct this object. Which constructor to use when you want to construct this object. And then the only difference between this code and the code from before is that inject annotation on the constructor. So now we know how to tell Dagger how to construct this object. Now we need to tell Dagger how to find it. And for that, we create something called a module. Modules are classes whose methods provide dependencies. And to create a module, we just create a class, give it a name. The name doesn't matter. We annotate it with @module. And this tells Dagger, this class will tell you how to provide dependencies. And modules are designed in a way where you can mix and match them, you can combine them, and you can basically compose them together or separate based on your specific needs at a specific point in time. Inside modules, we have methods that tell Dagger how to construct or how to provide these dependencies. What's important about these methods are the end provides annotation, obviously, their return type, and so in this case, the connection helper, and the parameters passed into this method. So in this case, context. The name of the methods doesn't matter, but just traditionally, people have just called it provides and the return type. So provides connection helper. So when Dagger goes and tries to create a connection helper, it will notice that it needs context. And it will say, okay, I have this dependency on context. Do I know how to create a context or how to provide a context? In our situation right now, it doesn't know how to. So in this situation, if you go and you try to build this, it will refuse to build. You'll get a compile time error. So we need to provide it a way to return a context. So we provided a method, we annotate it, we say this is the context you should use whenever you find a dependency that requires a context. But even though we told it to return a context, this isn't actually a defined variable yet. We don't have an instance of context. So in this case, we just create a constructor for the app module. We pass it a context, and we say, this is the context you should use, or save this context, and whenever you need to use provide context, this is the context you should return. So now we told Dagger how to construct our dependencies, how to provide them with their own dependencies, and how to group them into modules. The only thing that remains to do is actually initialize this, or combine this module by itself, technically, into an initializable component. And for that, we use the component annotation. The component annotation actually goes on an interface. The modules are actual concrete classes. Components are interfaces. So Dagger actually goes, looks at what's in this class, looks at all the modules that are linked to it, and it creates an implementation that you can then use to extract your dependencies. In this example, I showed, I put void inject main activity because this is how you do it in Android. We don't have constructors for activities. The system creates them, so you have to tell it asynchronously. I need to be able to inject into main activity. The same thing you do with services, fragments, any class that you use that you don't want to use constructor dependency or constructor injection, you tell it I need an inject method that I can use later. And then we want to go ahead and initialize it. And the way you initialize it is, so Dagger app component is the class that Dagger generates for you. App component was the name we gave the component. It just adds Dagger in front of it. It creates a builder for you to actually supply it with modules. In this example, we needed to give module the context. If you don't provide it, it will try to build using the default constructor. And if that fails, it will just crash. So you'll never get past this point if you're doing something wrong. You You can't get this one user that crashes on this one weird Chinese device. It either works or it doesn't. And then a common pattern is to initialize a lot of this in your applications on create method. You just create it, you provide a way to get this component, and then in your activity, you tell it, this is my injection point. I want you to inject a connection helper into this class. And because we don't get to actually have a constructor for activities, we have to manually tell it, I want you to inject now. So you tell it, get this component, inject me. Me is the main activity. It goes into that generated code. The generated code would say, I need to inject a connection helper. Do I know how to construct a connection helper? It'll go into its modules, find everything it needs, return a fully set up connection helper that you can then just use. And you can do this with as many dependencies as you want. All right, so that's the basic Dagger, basic dependency injection setup. But now let's go into some more fun stuff. So Dagger provides many different options that you can use to define exactly how you want the objects to be created, how you want them to be destroyed, how you want your modules to be combined. And I'll give you a little brief overview of the more useful ones, show you kind of how to use the more complex ones. And it's really depending on your needs to a connection helper. And then you switch to some other activity and you need to check again if you have a connection. If you annotate it using single, you'll get the same instance every time. So there's no need to create multiple instances. And this is very useful if you have like HTTP connections, which are very one other thing I like to do, especially with singleton, but with all the scope annotations, is I like to put that annotation in the class itself. And that kind of helps document the class to say, this is actually a singleton. And you don't, like, it lets other developers know, this is a singleton, just be careful if you change it, if you add something, it might be shared. So kind of think about that. One other thing is in Dagger, when you annotate a provide method in Dagger 2 specifically, not in Dagger 1. If you annotate provides method with a singleton or with any scope annotation, you also have to annotate the component that it goes into with the same annotation, and that lets Dagger know the dependencies in this component could be either singleton, they can be reusable, but this is the scope that we hold. Another very useful annotation is reusable. And this lets you limit the number of items you use, but it's not necessarily a singleton. So every time you call it, it will provide a new one. But if you're done, you gave up your last reference to that object, it can get reused. So Dagger would keep a reference to it, but it won't generate a new one every time. It would only generate a new one when one is required. And again, you have to tell the component that you're using this scope. Lazy injections and provider injections are, again, very, very useful, especially when you want to defer instance creation until later. Perhaps you only need it, you only need this object if something goes wrong, or if the user takes a specific action in the app. And like basically, you don't always need it. You only need it under certain cases. And then the provider injections is similar. It lets you create the same object over and over, multiple times. So let's say you want to create views on demand. You can tell, provide me with an image view every time, let's say, click a button. Provide me with a new image view, or provide me with a new, predefined or pre-configured user object. Just say provider, you get your connection helper provider .get, and you get a new one every time. The qualifier annotation is something really cool, and it lets you, it both lets you create your own annotations, so it's not something you use by yourself. It's not something you use by yourself, but by itself, it actually lets you extend the behavior of Dagger, and kind of lets you do whatever it is that you want to do. So I'll just give you a quick example of the annotation called named, and that lets you basically distinguish between two provides methods that have the same signature. In this example, provides REST adapter, or two of them, and you can distinguish them between them using just a name, basically a string name. And adapter 1, so when you go and inject it, you tell it, I want you to inject a REST adapter here, and the one that's named adapter 1. Subcomponents and scopes are very useful. Subcomponents let you extend your regular components. So for example, you have a user profile activity that you need specific, basically specific dependencies for that view that you don't need everywhere else in your app. Subcomponent will let you group that, combine it with your default app component, and then everything gets injected or created and injected at the same time. So this lets you kind of manage your memory and lets you define what you need when you need it, so you don't have to create everything at the same time. Then you can use a combination of scope, qualifiers, subcomponents, basically mix and match to get whatever, kind of whatever behavior you want, whatever kind of suits your needs. And the last thing I want to say, since I'm running out of time, about testing with Dagger. I know I said a lot about testing before. Dagger doesn't directly help you with testing, with unit testing, but it helps you indirectly because you need to specify the constructors with your dependencies. You can just supply your object with mocks. So that's kind of how it helps you with testing. Dagger does help you a little bit with espresso tests, because you can override your modules with ones that provide mock data or mock objects. So it does help with that. You can provide a REST adapter that just returns simple data. And that's it. Any questions? Shall be bleed. Okay.